Look at this digital dashboard. It is an avalanche of activity. Abstract shapes, pulsing indicators, and overlapping boxes flashing constantly. If you know basic JavaScript, you know how to execute simple commands. You can write a script to open a menu or change the color of a button when a user clicks it. But a modern web application demands thousands of those interactive events happening at the exact same time, all on a single screen. If you build that manually, you have to write code tracking every single state change, remembering what is open, what is closed, and what data is currently loading from the server. Trying to build dynamic web applications with those basic step-by-step instructions leads to a total collapse of the development process. The sheer mental overhead becomes impossible for a human to manage. The legacy method for building web pages relies on direct document object model, or DOM, manipulation. You tell the browser exactly how to change the document, step by manual step. Friction explodes when multiple scripts try to update the exact same interface simultaneously. One script tries to open a chat window, while another script tries to delete it, and the two instructions violently collide. This is spaghetti code. A neat branching logic network rapidly devolves into a tangled knot. This architecture is highly fragile. A single red wire snaps, causing the entire structure to shake and turn gray. Fixing a minor sidebar issue breaks the profile elsewhere. Engineering teams realized that adding another simple library wouldn't solve the problem. They had to abandon their old mental model for user interfaces entirely. The traditional way of building the internet became its biggest bottleneck. Coding stopped being about creating new features and turned into the act of managing chaos. Facebook engineers built React to survive their own scaling crisis. They needed a system that wouldn't buckle under the weight of a platform serving billions of people. React introduces a specific rule. You have to stop thinking about building entire web pages. Instead, you build components. A component is an isolated, independent piece of user interface that controls its own behavior. Think of traditional web development like handcrafting a completely unique vehicle from scratch every time you need to drive. React works like standardizing parts on an assembly line. Shifting your focus from the macro page down to the micro component neutralizes the mental overload. You only have to think about one small piece of logic at a time. Let's conceptually deconstruct a massive web interface to see how this works in practice. A complex web page wireframe suddenly shatters into dozens of distinct floating geometric blocks, isolated atomic components like navbars. Isolating a single button, the square expands, revealing a linear logic flow. Giving you reusability, it rapidly duplicates into 50 identical squares. Write once, deploy anywhere. This isolation also protects the system. If an error occurs, it is trapped there. It cannot spread and crash. React became the industry standard because of this modularity. For the first time, massive teams of engineers could work on the same application simultaneously, without their code colliding. React tamed the scaling crisis by turning chaotic UI development into a predictable, reusable ecosystem. If we zoom back out to view the fully constructed web application, it looks exactly as active as it did before. This diagram reveals the underlying architecture. A messy, overlapping cloud of abstract shapes smoothly snaps into a rigid, perfectly organized grid structure. The volume of data hasn't decreased, but as the grid pulses in an orderly, synchronized wave, complexity is contained. Despite its enterprise-level power, React is built entirely on the JavaScript you already know. Stop writing fragile legacy code. You can leverage your basic JavaScript knowledge today to build your first React component and bring order to your next project.